Now, would I like to call our next speaker, Santh Raul from Aditya Birla Group.
Thanks to you all for staying back after 4, beating this Bangalore traffic. Yeah. So I'll be taking you through some of the journey we have gone through and what is my thought on this. Maybe I'm not the complete expert. I'll learn through your interaction in future. Yeah. So thing is, one question I would like to ask. How many of you already have been using AI in your asset reliability? If you can put your hands off, I would like to understand. Okay, two people in the. Okay, now from two, I'll come to again ask you the same question. Yeah, like how many assets you cover? Like how many equipments you cover in your plant? It's a 50% asset you cover through AI. How many percentage, if you say, if I may ask you, sir? What the percentage could be? 10, 20, 30, 20%. Yeah, good. Then I'll not go for this question because there is no point in asking 80 to 90% how many people are there. I come from Aditya Birla Group. I'm a practice lead in data science solutions. So I have gone through around 19 years journey in industries, R&D, corporate governance, and landed into data science. I'm practicing data science in last 7-8 years. So what is Aditya Birla Group? People understand is a fashion. People understand is metal. People understand is cement. Yeah, we produce all of them. So it's into fashion. It's into metal. We have Grasim Industries are there. So we are in fashion from starting to ending. We cover all of them. Carbon black, like that. To every function we have a COE function. Like people don't understand, some people don't understand what group data analytics is. So basically I come from group data analytics. So to help every businesses are autonomous, so help every businesses, we have a function called group IT, group data analytics, group sustainability, group economics, like that. So we advise our group companies and help them excellence in those areas, making policies and all. So let's come to the subject. Yeah, that was my advertisement. So now let's come back to the game. So let's start with something that you all know. So every asset has a cost. How much? It starts from a company's 2000 CR to 1 lakh CR, depending on the sector, depending on the industry size. Cement, steel, aluminium, mining, all those land into a different cost sector. What are those? Those are the capitals invested by the company. Now to maintain that capital, if you're buying, if buying is very easy, you can buy a house, it's okay. But how do you maintain that house or car? For example, you can buy a high-end car or you can buy a small-end car also. But how you maintain that car to operate, if you don't invest in that maintenance, it will not operate. The cost of the maintenance is particularly around 2 to 4%. You invest in maintaining those assets. So that's coming around 20 to 60 based on that. And people call it as a cost. No, it's not a cost. It's an investment to maintain, keep running your business continuity. If you don't do that, your production loss will happen. Then your maintenance cost will go high. Shorter asset life, and certainly the customer and quality and customer impact will be there. The safety and environment will haunt you. Then what we should do? Reliability is not an expense. So don't think reliability or maintenance is expense. It's an investment what we are doing to maintain the assets to keep running our businesses. Yeah, are we all with that? So let's start with something which we also know. That's the evolution of the maintenance, how it started and what was their thought at that time. It was something around 1970 to 1950 to 1970 era. At that time, people were looking for how much I can extend my machine to run. I can run to the failure, then I'll operate it. So their problem of the question was what broke, and they were looking for how quickly I can maintain it or bring back my machine to running condition. That was their KPI. So how fast I can repair it. Then comes the time which called as 1970 to 1995. It's called preventive or predictive maintenance. Most of people have heard about it. So when should we service that machine? So basically it's a planned maintenance, also people call. When should I service that machine? Then it comes to calendar based PM, shutdown planning, OEM recommendation. These are came into picture at that point of time. So PM compliance, how I'm complying with the PM, that was the KPI at that point of time. So what it resulted in? It resulted in reduced breakdown. At the same time, it resulted in increasing the maintenance cost because we were going for the over maintenance sometime. Also at the same time, we were not knowing that if this machine needs maintenance or not, because it's a schedule we are doing the maintenance. Some other machine might be needing that maintenance, we are not doing it because schedule has not come and it was getting breakdown. So that was the time-based maintenance, pros and cons was there. And then we come across the condition-based maintenance or proactive maintenance. So we started measuring the asset health at this era. So what happened? Oil analysis, thermography, vibration measurement. So these things came into picture. Until then, this was not there. So IoT sensors started coming into the picture. SCADA, historian, sensor, the technology has supported that. So what happened? Again, improved reliability. Now, along with the improved reliability, the cost of inspection has gone high. Now you have to inspect every equipment. Also, you have to analyze every equipment, what data you are connecting with that. So that was very challenging. Now I have a lot of data. What I'll do with that data? Who will analyze that data? And that to 24/7. I can do it for a day. I can do it for a week. But I cannot do it for thousands of assets 24/7. That's a very difficult problem. Then people came up with predictive maintenance. 2015 to the present time, people were talking about predictive maintenance. What will fail next? So thing is, people started building those models. So statistical models has come up, machine learning models have come up, anomaly detection started coming in. Then what is the useful life? A lot of reliability models have come up along with that. So unplanned downtime has come down. So now still reliability has improved because of unplanned downtime has come down. Then what? We are in today. What the future is? Future is looking for prescriptive maintenance. From predictive, now I'm looking for what I need to do. The maintenance manager are asking, you are saying that this machine can fail, but what I should do now to prevent it fail before you say that it is supposed to be failed. So how I can bring back my machine's life, which is deteriorating, again to the normal condition. So that the recommendations are coming in. There the knowledge graph is helping, there the other technologies are coming in, AI is helping, all those things are coming into the picture. That's why, because we didn't have that unstructured data along with us and we're not able to use that. Now we have a capability to use that. So we know how the machine operates. That's why we are able to leverage that. So what it resulting in or what it will result in is the reduction is maintenance risk or maintenance cost again. My reliability is continually improving. Now I have to also look at the cost. I was saying in the initial that maintenance cost, we should not think about cost. Now we should think about cost. Okay. So the framework is clear. So maintenance cost, we should invest it. Now I am saying again, we should not invest it because we should invest how to prevent that cost also. Okay. So yeah. This is my favorite thought which I come across. Don't monitor your assets in isolation. Monitor assets in the context of the process. Yeah. So what happens? Or usually what we are doing now, all the IoT sensors, the people, lot of IoT sensor people will also be here in the stall I was looking at. So what they do, they put a sensor that collect the data. Or you also put a sensor in your machine and collected data, what you do? You look at the vibration of that machine. What you do? You look at the temperature of that gearbox or that machine. You look at particularly how my machine is operating in that state. Oil analysis, maybe. But it is a machine. It's the same machine. But machine doesn't operate like this. Machine, for example, in this room, if we stop the AC, you will behave differently. If I turn on the AC, you will behave differently. Okay. So you behave differently or react differently to the environment. Why machines should not? Machines also react differently with the environment. What is that environment? That environment is the process what you are operating with. What flow you are putting in, what load you are giving to the machine. So it's called context. So once you start observing or analyzing the process, you build the context. Now context drives your diagnosis. Earlier your diagnosis was with only the machine's parameter. Now you are integrating the process. So your process becomes a context and your diagnosis become better. So correct diagnosis will drive good actions or right actions. And correct actions will drive the business value. Otherwise, we will go in a cost direction. So basically, my message here is, again, I will say, don't monitor assets in isolation. Monitor assets in the context of the process. So why most of the DCS alarm miss the problem? We have a DCS alarm, right? Every plant when we operate, we have a DCS alarm or threshold limit. Why they miss that problem before machine is failed? For example, there is a vibration. There is a vibration, you see. So can I have a pointer? Yeah. Okay. You see, at the point when DCS alarm limit has crossed, it gives alarm. But at the point when it gives the alarm, machine has already started deteriorating. Most of your alarms are at the threshold of the OEM's limit. That means once you reach to that alarm means your machine has started deteriorating. You cannot bring back that. Whatever damage happened to that machine or during the period you operated above the threshold limit, that is gone. You cannot bring it back. Now, DCS alarm we say triggers late after damage can happen. You can say, I'll bring back that threshold limit. I'll say, why not? I'll give the DCS alarm at this limit, at this point of time. Okay, let's see. Same vibration. Yeah, I'll bring it some other context now. This is the environment. What is the speed of that machine or fan? What is the current of that fan? What was the temperature it was operating at that point of time? If you combine all this together, again will you say this is a problem or not? This vibration is a problem or this vibration is not a problem? This is coming from the environment. So this is not a problem. This is reacting because of the environment is behaving something like that. Hence, we should not trigger the alert at this point of time. Where we should do that? You can ask me again. Like if I do not do that, what I should do that? Where I should do that? Look at this point. This point, what happened? My temperature has gone high, my vibration has gone high, but my speed is normal, my current is normal. Okay, this is a problematic state. But how do I detect it? Is an expert who is sitting with your condition monitoring team or your technical services team, he will be monitoring this all the day? No, he cannot. Then what? Then I look for some solution. What is that solution? Solution is look for some data. So multi-equipment system data, that is you can say that like this is the physics, what I am bringing in to the maintenance data. I am integrating that and I am building some models. Here the models are helping. Okay. So You have a first principle model, you have a statistical model, you have an AI model, whatever model you can build, but it's okay. But here the models can help. Once you build the model, you have real-time validation of those models. Now model can trigger. Now model can continuously operate for 24/7 and see that which my asset or anomaly is happening. With the early warning, what we'll do, you will have another engine which is called inferencing engine, what we come across like rule-based reasoning, statistical inferencing, deviation from the normal behavior. So these are the inferencing engine. What happens? This alert, now this is the warning region. When it is increasing, it is saying that why this is happening. Now once I know why this is happening, I can say what I need to do. Then this is called the recommendation engine. If I know what is my problem is coming from, I can say that what action I need to do. But here I don't have to stop, because this is where the problem goes wrong. People don't trust these recommendations. Sometimes they will say that this recommendation or these failures are not correct. So continuously you have to do a feedback to your model. This thing what you said is wrong. Now correct yourself. Next time he'll come back in a better mode. How you build this ecosystem? This is very, very challenging, comes in here. You can connect with any of the experts to build an AI model. I'll tell you here that how the success or the journey will go through when you build a model. Model building is not a problem. Today's world, a lot of experts are there who can come across and build your models. You can give the data, they can build the models. But what actually works? What actually works is here. Many organizations believe that project fail because of models are not good. No, it's not. It's not the exact true. What my experience says that the biggest problem is trust of the people. People don't trust the models. Why? Why people don't trust the models? We have to ask that. And how I can bring in back that trust. It starts with the data foundation. If you don't have a database or data storage, how you can build the model? Some people say, or some industries say that we have a lot of data. But if you see, those data are in silos, some staying somewhere in some PC, some person's PC. How will you use that data? Some person has a DCS, sophisticated data is stored in the DCS, but they don't have a connector to bring in that data out of the DCS. So you have to bring an ecosystem that my industrial data should be come to a usable form. Anybody can consume it. Once I have this, you will face a challenge. What is the data is not reliable? How now I can bring in the data to usable position. I can give it to somebody, but the data is not now reliable. Why? Because I have not checked it when I was collecting it. So you have to overcome that challenge again. That's called data quality. Now you have to put a data quality engine live when you are collecting that data, not after collecting that data. Because when you are collecting data, you need to know that my data quality is wrong or right. If it is not wrong, I have to look at the root cause why it is wrong and correct it at the point of time, so that my 1 year's journey or 1 month journey of the data collection doesn't go back. Or else what will happen, 6 months, I'll collect the data, look back and see that my 30% data is not good. I will not be able to use that data. Once you fix this issue, you will come across again problem. What is that problem? That's a scaled deployment problem. You can build one model. You can build 2 models, 10 models. But how will you build thousands of your assets model? That's a scale deployment problem. So here brings in the platform and AI models, what new era has come up. So unsupervised learning, context-aware models, these are the help coming in here. The how you design that model, that helps. The problem of scaling is important. You build one model, lot of solutions come with one model or 2 model. You can solve your one gearbox problem. When you say, like you said, 10% coverage is there, that's the problem. Because you are covering 10% of your assets. Now what about the 90% other? If 90% of any of the 90% machine, any one of the machine from the 90% fails, your production line fails. Are you thinking those are not important? Yeah, those are also important to run your machines consistently. Once you solve this problem, then comes the biasness or ML models false alert problem. What is that false alert? ML models are come with the probabilistic method. So it's not true that it will give you the 100% correct answer always. So they also do the mistakes. So once this problem starts, your trust will be loosened from the users. So how you overcome with that? You will have a human in loop. So somebody is looking at those alerts what the model is giving, and you are giving the feedback to that model again. Now once you give that feedback, somebody has to listen to that feedback. Feedback may be in any form. Now we can give feedback in text language also, and somebody has to listen to that feedback and bring it back to the model and train the model again automatically. You cannot sit and train the model automatically that this is the wrong what you have done. You have to learn it and give it back the feedback. Next time when you are giving the alert, you should give the better alert. Then comes the bigger problem. You can solve this also. Now what about that change management? This is where the bigger effort comes in. You have to involve your operators while going this journey of AI model building, human feedback, all those things. You have to involve each layer of operator, each layer of your managers. Bring in their inputs, incorporate in their in the journey of model development. And you have to also train your people, because people are going to use it. Here comes a journey of around 4 to 6 months. It takes a longer period of time to go through a change management process. Give a success to them, showcase a success, celebrate it. So that's a bigger challenge where it comes to bring in the asset reliability in the industry's context. Now, once you overcome this problem with the adoption, what will happen? You will face another problem, which is called confidence. So basically your 4 pillars, if you cover or establish this from 5 pillars of industrial foundation to the adoption, then you reach to the one thing which is called trust. And this is the only thing which will drive your asset reliability journey and adoption in the plant. And once we do it, we'll have a stronger foundation, fewer false alert, faster response, lower cost. All these results will start coming. But you have to be patient and look for a longer journey for that. Yeah. So I explained everything, whatever it is. This brings in a business value. Business value of current challenge to a solution. What is the current challenge? Asset visibility gap. That is the bigger challenge you are looking at. Your asset is there, but limited visibility across the assets. Health monitoring is done manually, sometimes done with sensor wise. Periodic inspection misses early signs because nobody is there to analyze it, or analyze it in a periodic basis, maybe in a week time, in a fortnight time. Expertise gap. One person can analyze a better way. If you change that person, the other person will analyze same data in a different way. So how many people you can train? Now, the expertise are very limited in the industries. And our asset base are increasing. Industries are growing and assets are increasing. But how many people we can train over there? And knowledges are in silo. Like knowledge resides with the individual. If individual goes, the knowledge goes along with him. Also, if you have a network of assets in different places, different locations, so any problem happens at one place, doesn't communicate it to other place. They don't know. The same repeated failure happens. So these are the challenges industries are facing as of now. So how to solve it? What AI solutions is giving you? If you are building that foundation of 5 pillars, What AI solution is giving you is a continuous health monitoring system. That asset visibility gap has been reduced. My asset, somebody is there who is looking and observing 24/7. I'm assured about that. Earlier, I was dependent on somebody. Earlier, also, somebody was capturing data, he was not analyzing. Now, somebody is there who is analyzing. Experts gap, what is there? The expert is analyzing, along with that, expert is taking some decisions. Decisions is what? He is recommending somebody, go and do this, go and do that. So, this is the inspections or recommendations he is giving to maintain that machine. Knowledge silo. Now, the interaction of human is happening with the AI machines. So what will happen with that? You will gather the information or knowledge or expertise of the users or your software. That will bring in a lot of information which was not there in the book. That will come into this platform. And you can use it recursively in a period of time. When you have a growth of that knowledge, it will be beneficial for your organization. It is not about, what I'm explaining is not about only asset reliability, it's about the business transformation. So if you have to go for a business transformation, you look for these kind of models. Ultimately, all these contributes to a business impact. Without business impact, none of your initiatives or none of our initiatives will be accepted by the management. So what outcomes we are going to give is better availability. Why? Because I'm monitoring the asset in a 24/7. So I know when it is going to fail. So I can do my maintenance or plan my maintenance prior. Cost is lower because unplanned maintenance is going lower. My machine life is increasing. Safety is increasing because every unplanned maintenance brings high risk of reviving it. So if you have a very planned maintenance, you know your machines are there, safety procedures are there, you are reducing almost 80 to 90% of your risk appetite. Yeah. So from here, I'll take with one note which is called don't monitor the assets in isolation. Monitor how assets behave within the process. Context matters more than a threshold. Thresholds are always there, it had been there, but now context is more important than that. Why that increased and gone beyond the threshold? Threshold, it can increase beyond the threshold, it's okay sometimes. Reliability is not about predicting the failures, it's about improving my business performance. I'm not looking for machine to run 100% of the year. Why I'm looking for? That's important. What business value I can bring in because of my machine is running. One threat comes in when you implement AI. It's called AI will take my job or AI will replace me. No. The reliability engineer who was there, please give that message to him that AI is going to make his life better. He's not going to devaluate him. It is going to make his life better because he was not able to observe thousands of machines. He was not able to. Now he is able to, with this information, he is able to go and pinpoint and observe at the focused areas where his expertise are needed. Earlier he was doing a mechanistic work with a routine robot kind of observing it. Out of that, maybe 90% was not a problem at all. He was doing that job. Now he is only looking at the problem, where the problem is, what solution he can bring in. So he is bringing into the table better value to the company. So his value is going to improve with this AI augmentation. So with this, if you have any question or connect to me, you can ask. Yeah. Thank you so much for listening this evening.